It's my pleasure to introduce Carmen Sidbury. She's working right now as an independent consultant. She had been, prior to that, the Associate Provost for Research at Spelman College, and one of the things she did in that position was to coordinate initiatives for undergraduate student research. She had also worked at one point at NSF as a program officer for the Graduate Research Fellowship Program in the Education and Human Resources Directorate. And one of the things that she developed there was the Engineering Innovation Fellowship Program. So she's worked in the academy, she's worked for the government, and then she's also spent time in industry. She was at Bell Labs for a number of years. Her PhD is in mechanical engineering from Georgia Tech. So welcome, Carmen. Thank you.
So good morning, all. I must say that I count this as a privilege to be here. It's really for me it warms my heart to have folks at liberal arts colleges thinking about engineering, and even more so, how do you perhaps integrate that into your curriculum, but even more so that we're thinking about the engineer of the future, which this term, Engineer 2020, which is our entering class, perhaps. And so it really strikes me, I think probably 15 years ago, when I was at University of Washington, there was a big group of engineering deans and folks in leadership, big team of folks coming together thinking about the engineer of 2020. And a lot of the focus was on what we really emphasize in the liberal arts education, lifelong learning, a lot around working in teams, how do you communicate, how do you design things that with a sense of the culture or the environment that you're entering. And so it's really been a lot of the conversation, at least, has been around how do we bring the two together. And so for me at Spelman, a lot of my excitement has been around, I think we're in a really sweet spot to think about liberal arts education, but we have been known very much for, I'm still in this I got to make this transition. It's been about 6 weeks now that I've moved on from Spelman, so the still something I'm getting used to. But known very much for African American females who go on to get PhDs in STEM, and so a lot of that is how they start their journey at Spelman.
And so Spelman, a women's college.
And Spelman is a women's college in Atlanta, Georgia. About 2,100 students, 98% African American, and so founded under the premise of a religious school, initially thought to prepare women for becoming teachers and home economics and working perhaps in nursing. And so it's evolved, and it's very much one of, I think, one of the institutions in the nation that really prides itself in, one of the taglines is free-thinking women. So if you think about that, but it's really interesting too, some of the traditions that though are held on to very closely by our alums are somewhat very traditional. So we have Morehouse College, just to kind of give you a context for where we are. Morehouse College, all male, and it's 2 minutes outside the gate, and we're all of these institutions, Spelman College, Morehouse, Clark Atlanta, are all, it's almost like this campus. You walk from one to the other, and there's a lot of historical relationships. So we're part of what we call the Atlanta University Center Consortium. And so there are a lot of things that come through the consortium that then filter out to the individual schools. So our dual degree program was initially founded under this kind of centralized model, that we would share courses, that we would not duplicate some effort. So anyway, but it's for me a very exciting opportunity. And so even as I move into this new role, and so just to give kind of a context, you know, I started probably non-traditional in a sense, introduced to engineering as a junior in high school. And so many people think it's middle school, you got to get them then, or we lose them. And so I've always kind of bumped up against not quite fitting what everybody says, how you do the script. But I think for me, a big thing, and this is what I'm really going to talk more about, is about building the identity, even if we're coming into this, you know, from a non-traditional path. And so, started at Clemson University. They had a pre-college program. I spent 2 weeks of my summer between sophomore and junior year there, really an intro to engineering. I really had no concept of what this was. And so, back up a little bit, I grew up in a very small town called Sneads Ferry, North Carolina. I've come to learn it really wasn't even officially a town. It was a village because we didn't have any, we didn't have a mayor, and only until the next town wanted to annex us about 10 years ago, there was this real strong play that says, no, we want to maintain our identity. So very small, rural, coastal town. Most people were farmers, or they fishermen, or they worked on the military base, Camp Lejeune, as civilians. So I grew up with grandparents who raised tobacco, and when the tobacco season was off, I went to the local fishery and headed shrimp as a way to make my summer living. So a 2 week, 2 weeks at Clemson University in air conditioning and hanging out with other folks was, wow, that was, I had arrived. And so I learned about engineering there, not just the person who drives the train, and I really got excited about it. It really gave me a context for what I could do with my desire, my skills in math. I was always pretty good at math. But it's all relative, right? So I'm valedictorian of my little high school of 105 students. But when I got to college, I didn't know what even calculus was. And so all my friends talk about, yes, we had AP calculus, and I am scared to death, right? Because it's a new thing for me. But so for me, though, the big thing was all along my path, there's been someone to encourage me. And while I didn't quite have all of the language for what do engineers do, what does this path look like, and in some ways maybe that was a good thing, because I would have really compared myself and said, no, I self-select out of this process because I don't look like what people say this journey looks like. So, but I think that there are lots of ways we can really think about building identities for students as engineers. And this may feel a little soft for you or a little fuzzy, but it's the thing that I'm really now taking as my mantra and very passionate about. That, you know, it is very important, something we call self-efficacy, and it's around believing that you can do it. And so for engineering students, for many of them, it still is a new phenomenon. We may not have role models, and so that's part of my transition into my new role, to get out and that we really do live and breathe, and I'm not such an odd person, I guess, but this belief that you can do it, that you really can, you know, build around, you know, the classes, some of the experiential learning opportunities. And perhaps I really believe it takes a village to really make this happen. And so I think all of us have a role to play. And so this is really grounded in research around just about efficacy building. And so there's been some effort in the engineering education space, and as we think about designing our programs, to really have this be part of the grounding of the work you do. And so really putting this in a lens on this from where I stand in terms of looking at underrepresented minority women, particularly looking at engineering. Under 5% of degrees to African American. Well, this is actually underrepresented minority women. So this includes African American, Hispanic, Latino, as well as Native American. So there is an issue that you don't see other folks perhaps that look like you, that gives you this false sense of this is not a field for you. So if we go though to the medical sciences, biological sciences, we have a bigger base of folks to choose from to think about who comprises the STEM, who's in this pool. And oftentimes we group them all together. But when we really unpack the engineering piece, we start to see why there has to be some really, I feel, some intentional interventions to really, kind of promote the message that yes, we can do this. And in fact, for many of us, it's important, I think, to tell the story that others have done it, so therefore you also can do it. And so I think the Smith story is really a compelling one. And while I think Susan is a little modest about how great you're doing, it's an important story to be told, that I think that women are doing engineering, they're thriving in engineering. Perhaps they're not coming through, if we were to say, looking at the model, what engineering has looked like, perhaps they don't quite see themselves in that mirror. And so I think it's important that we do a lot more around this messaging. And so in this main components of efficacy building, and what I think too is really essential in terms of building students' identities, is to have some vicarious experiences. And so we see this now in REU experiences. I'm going to showing you an example of a recent one that at Spelman a couple of years ago in a summer program we did. But verbal persuasion is another one, or social persuasion. And we find that, especially our students, to say yes, you can do it. This is back to my previous thing, that we can't underestimate the value of that. And I can tell you, for me, my journey has been often someone said yes, you can, and I said okay, yeah. I hadn't thought about it necessarily, and it may sound a little. Maybe I didn't think about this, but imagine an 18-year-old, a 20-year-old. We're still very, very impressionable. And I think for me, thinking about faculty members and educators have always been like very important role models for me outside of my parents. Because my parents didn't know what the journey, getting to a undergraduate degree was like. So in my family, while all of my siblings, we were all encouraged to go to college, my parents didn't go to college. And so my teachers were very important in helping me to shape what I could be and to think about higher ed. And so even my journey into a PhD program and graduate school was something for me that occurred my junior year in college. Something about junior year of high school, junior year of college. I guess I start maturing a little bit, and oftentimes people see something in me that I hadn't seen in myself. And so I think this whole identity building, and oftentimes we're going to have to see that in some of our students. We're going to have to also help them see it in themselves. And so this content mastery, which is often the piece around your training, how did you do in calculus class? Have you had the right math class, the right prerequisites? But it's interesting thing here for, we've seen too with women, that while you may do very well in a course, if you're not told to how well you're doing, you often self-select out because you don't think you're good enough. And this kind of ties also into the physiological state. There's some issues around, or something that's been talked about a lot, stereotype threat, imposter syndrome, where, they're overcoming those challenges really is something that I think our interactions with students becomes very, very important. And so while it may, maybe it doesn't seem important, but I can tell you it really, really makes a difference. That if we take the time just to reinforce students that they indeed can do this, that they're supposed to be where they are, and that we also encourage them to stay the course. And so sometimes, talking about these things, it's a little uneasy or a little gray area for people, but I think we can't shy away from that. So while many of our students, especially if they're at the institutions, your institutions, it's a very comfortable place, often is a very nurturing place. And in many engineering schools, it's a very competitive, it's a different kind of world. So arming them as they move into that space, that they're armed with both the analytical and the content mastery, but more so how they feel about themselves. And so I think it's just, it sounds kind of fundamental, but I just want to stress that how important it is that we really spend some time on that. So I'm just going to this was an interesting project that we introduced in a summer bridge program for our incoming first-year students back in 2013. And so one of the things that we were challenged with a bit was really giving students a sense or a taste of what engineering is. This project we designed not necessarily required any math skills or any prerequisites, but to some degree to be a bit uncomfortable with the uncomfortable, things that they hadn't done before. So this was, and I went and recruited a good friend of mine who, mechanical engineer, more controls guy though, who worked in industry, and really he was also looking at trying to transition into higher ed. So this project was really a fun one of, we took a couple of servo motors, took the laser diode out of a pointer. So part of this project was really moving through the steps of the mechanical assembly, so kind of hacking, for one word, maybe we could say the pointer to take out the diode there, laser diode, wiring the circuit, which was a brand new thing for our students. Programming, a microcontroller, and then controlling the motors to generate some very basic shapes. But there were some things in there, that as you go through the process of, it's not just, the motor, it doesn't just stop right on a dime. But then how do you compensate for those kind of things? And so moving through students really through this process, and it was really, initially when Jerry presented this idea, I'm like, ooh, this could be a bit intimidating and definitely kind of run some students off because it seems a bit of a big challenge. But let's go into this and really see where they go with it. And so this is just kind of a pictorial of all the pieces of it with the motor. We start with the schematic and really tying all that together. And so it really required students to really try a lot of things. And so a bit frustrating for some as we move through the process. But key here was that I made sure we also had a number of people working with students too. It was okay to make mistakes. It was okay not to know. But it wasn't okay to quit. And that was a big part of this. And so, and this is some of the basic shapes that eventually students were able to make. But this process of starting off here to the left really challenged with, oh wow, where are my coordinates, how do I get there? And eventually moving through the process, and you can see some of the play in the motors showing up here. But it was really after we talked to students through the process of how many students, initially coming into engineering, what they thought it wasn't this, right? It was some ambiguity about how much math, how much science. Is a way that I could perhaps use math and science. But thinking and this whole iterative process too of designing was not something that they really thought about. And so I want to say the majority of the students started not knowing, and this clarity gave them a sense of committing more to engineering. But we also had a couple of students who decided, wow, if this is engineering, maybe I'm not this is not what I want to do, because I didn't know coming in, but now that I know, I can make a different decision. But I really think, and it's still early, 2013 was this project. How many of those students are still staying with the program? It was an interesting project in that really moving from not such a realistic, I think, some of the projects or models that we presented to students in engineering. And this was a real one. It was one that my friend Jerry, had worked on a scaled up version of this in really thinking about positioning and how do you control motors and what goes into that whole process. And so it was a fun one. But along the way, the encouragement for students to hang in there and to stick with it. So I'm going to shift a little bit here and just drill down and talk about our Spelman's dual degree engineering program. And this, as I've had the opportunity to talk to many of you over the last couple of days, I think I'm reframing our problem a bit in that the dual degree program at Spelman, while it's over 40 plus years, it has it's a real program, I should say, that it was designed to be a real program. And so the thing that I looked at in this study was we've had some real peaks in the number of students who've gone through the program, and it's tapered off quite a bit over the years. But the big context of how do we look, what has this program done, and what is Spelman in general, how do we look when we map ourselves against the nation? And so it gives a sense of, while the numbers, the raw numbers, and this science and engineering includes psychology. So for NSF, they include psychology as part of their science and engineering. And so just to, when you unpack those science and engineering and you look at math, wow, in terms of black women who receive a BS degree, less than 1%. In that, but at Spelman when we look, and then we're a liberal arts college, but still, we're at almost 4% of the majors are math, and in fact, in dual degree, most of the majors are math majors. It's an easier transition to meet all the requirements for the undergrad in math, and then to think about moving to the engineering school. But the engineering numbers are just minuscule, and so. While the numbers there are small, the nation's numbers are small.
I'm having a little trouble interpreting this. Would you mind just, I know it should be obvious, but it's not. So on the right, engineering fraction of all Bachelor of Science degrees nationally or at Spelman?
No, so the all is nationally, and it's black women. So just that context. If we look at...
Okay. So the total of those is somewhat around 4%. No, you don't.
No.
Okay.
No, not the total. So it's Spelman and it's just really a comparison of what Spelman is doing in terms of their contribution to the STEM workforce relative to, and often we don't think a liberal arts college is doing that much in terms of when we look at our degrees. And so it's a tension point too for us at Spelman. As a liberal arts college, how much do you how many of your graduates do you want to be science and engineering? At Spelman, when we include psychology, over 40% of them are science and engineering, when we include psychology.
So almost half of the class is science and engineering.
Yes, including psychology. Now,
Yes.
psychology is our,
We understand.
yeah.
Are there BA degrees as well?
In some, so physics has recently added a BA degree. We have BA degree in environmental science and studies. It's a relatively new program, and even the BA in physics is. And it was really designed to address that you know, some of our physics majors, if they weren't going to do dual degree, they were thinking about education. And so, you know, and we have a grant that really looks at preparing STEM teachers in tapping into this STEM, these STEM majors, preparing them for becoming K through 12 teachers. Yeah.
So I'm sorry to hammer this, I just want my last time. So can I correctly say that Spelman has more than twice the
Yes.
percentage fraction of national, okay, that's what I.
Yeah, and
Now I
that's
understand.
that's the thing, and that's the thing that when I put that on, and even though it's for me, it's the idea, the thing of, yes, the nation isn't doing that great. We're doing something here. Perhaps there's something that we could share with the nation to help address this problem.
Okay.
And perhaps it's a stretch, but I think that there is something there, particularly around the math. And for us, though, when we unpack that, I know if we look at what our faculty looks like at Spelman, and particularly our math department, we're probably over 50% of our faculty in math are women of color. And so it makes a difference for students to see, you know, it's something about that. It is a lot of power in being able to see yourself. And I think also many of our faculty can also identify with some of the challenges that students will encounter. And so they kind of try to balance this imposter syndrome thing. It's a part of the conversation that they have with students here. And so, and this didn't come out so well, but the big thing I want to emphasize here is the dual degree engineering program at Spelman has a lot of other things supporting it. There is a coordinator, but a big thing that I think is, so this red line is something called Model Institutions of Excellence. And this was a $10 million investment from NASA, and NSF had these cooperative agreements with 6 other institutions that were deemed to be models of excellence to really address diversity in the STEM workforce. And so with that, in the case of Spelman, they were able to upgrade infrastructure, research infrastructure, really helping faculty bring students into the research labs. New courses were provided. They introduced this early warning system for the STEM majors, and really some real interventions to look at how do you help students along. Similarly, this NASA WISE program was a huge scholarship program that full ride for students. Also, it provided them internships at NASA. NASA was on the campus working with faculty as well in developing course content. And so, so this is an interesting one when I look at the number of WISE scholars WISE participants over the years. And so there's quite a correlation between when the WISE program was 50 plus students and even up to 120 students at its peak. And as the program went away, and so if we were to go back, the engineering, there is a little bit of a lag because students who are coming in, they're at Spelman and then they transition to the engineering school. But really, this program was a key piece to helping students stay in the engineering program. It helped recruit students and it helped to really provide a very supporting infrastructure. And I think fundamentally this whole core cohort model of having a really critical mass of students on campus who are really thinking like engineers and STEM scholars really made a big difference. And so just a little bit, about this relationship. You can see there were a lot of things happening that were really supporting the dual degree engineering program.
So that pre-freshman was for students aiming for an engineering degree?
Yeah, and actually it was pre-freshman, it was STEM majors, not just engineering, although NASA really, we really wanted to grow the engineering program. So students who, they were given preference, right?
So the program was very much dependent upon external support.
Yes, yeah. And some of these things, the research experience, you can try to institutionalize, like, and our biology department has really done a phenomenal job with having course-based research, courses that part of it is there's a research problem that may be tied to the faculty member's area of interest, and students get credit for that. We recently, a new award is bringing the postdocs into Spelman, because even for a faculty member, and the load at Spelman 3.3, so you can buy out of a course with a grant, but who's doing who's doing the research? How do you move things forward? And so looking at this model of bringing postdocs into this mix, and it's this award is it's only beginning its second year, but some of the faculty are doing a phenomenal job working with students. Their students are able to publish, but it's a tough one, and so having some external support for those kind of things are critical.
Did I understand that your dual degree program is not just for engineering, it includes other STEM disciplines? So math, for example.
So dual degree program is you have to declare a Spelman major, and yes, only math, physics, computer science, environmental science are participants in the dual degree program. Biology is not a one, and at one point there was something called natural science that really was kind of a non-major. Very few students choose that option, but yes, so yes, they do end up with a Spelman degree.
And they go to Georgia Tech for the engineering or science or math degree.
Right, so they go to an engineering school. Actually, there are 14 other partners other than Georgia Tech. Georgia Tech is the relationship was founded on that partnership. In the last 10 years, so Michigan now is a big, they take a lot of the students, but take a lot is there's 5 or 6 a year, and now they may get 3 to 4 of them, as opposed to the beginnings of the program. It was primarily Spelman, Morehouse, Georgia Tech, and that that run lasted for many years, and I think the competition, though, what we're seeing now for seats at Georgia Tech, pretty competitive to get into the engineering program. And so this is just some of the work around a big survey reach we did out to alum, and just asking them how did they decide on engineering. And so pretty standard stuff. It is about what they think about themselves, and I think what happens at Spelman, it's the things though that then you continue to offer them to help support them in their development. And so this is a little bit busy, but it's one of the things that really stands out. So this survey, over 200 women, African American women, who had gone through the program over a pretty long period of time, though. The folks responding, some had been out, maybe 20 years. But the key thing that stood out for me, and I was reading an article about how many people who major in engineering leave engineering, or they're not working in that space. And I'm probably considered one of those now, that I'm lost. I'm not really working in engineering per se. Some would argue. But what stood out here is many of the students, and I want to say over 65% were still doing STEM work, but 33% still working as engineers. And so, I'm like, okay, there's something perhaps that needs to be teased out in understanding, what is special. Is there some secret sauce that's happening as our students matriculate through the program and they stay with engineering? And not to say, I don't know, moving around, whether that's, good or bad. There are, of course, the folks who are investing a lot in this. A lot is based on the numbers. People count the numbers. Where do they go? The end goal is to produce more engineers, and so and engineers in the workforce. And so this has been a real, I think, an opportunity to tell the story of some of the successes, I think, that are in fact students who are coming through the liberal arts college and having that experience are really also contributing back into the STEM workforce. And I think the message also is for students who are thinking about career choices, and this is probably not surprising. I would say 95% of the folks we talked to were employed. So the issue of engineers, finding work it's not a difficult thing. Yes.
One comment and a question. This data is similar to the data that I quoted yesterday, where 40% of engineering graduates are no longer doing engineering. And this shows it more. Depends on how you define engineering. But the question is, do you have data that says about how long they've been out of school before they have moved out of engineering? Do you have any?
No, and that's another drilling down. So if we think about this survey, now it's like after you look at the data, wow, we should have asked another set of questions. And one of the things that really I am talking to NSF is to help, let's go back and understand this. When does that transition happen? And perhaps even what are some of the factors that determine it? So we did ask students, ask the alum, what were some of the factors in even their workforce or their work decisions. And of course the standard ones, family, family issues, whether you're relocating with a spouse or you're growing your family, those kind of things are pretty common. But it would be interesting to see, and this is kind of going back to our summer program of not really knowing what engineering is, and then when you really get into it and you've made the investment in time and resources, but then you discover it's like growing up. We figure out what we want to do when we grow up. But the more we can have these experiences that give students a sense of what it's like, perhaps we do that earlier. You know, does that make a difference?
You know, the fact that they're not in a job with a job title as engineer doesn't mean that they are not continuing to take advantage of their engineering training,
Yeah.
or that the nation is not continuing to benefit from that. I mean, they've still got this engineering mindset that they've developed, and you know, even if you're not doing, you know, official engineering,
Yeah.
you're still thinking differently. And you know, I don't think it means that the benefit of that education has been wasted because someone's got a different type of job.
Yeah, and I would argue with you. I would make that case very much. And often what we've seen, though, and this was a study of women who were STEM majors, this health-related occupation is a lot, it's almost flipped, that it's a lot lower for folks who are still in engineering, and more have moved to health-related occupations. And so, so yeah, I think overall, though, science and engineering, they're staying in the broader STEM workforce categories.
Can you remind us who was surveyed for this?
So this was Spelman alum or graduates who had affiliated with the dual degree engineering program over, I would say, 20-year period. And so we sent emails to probably 1,100 students and 215 responses.
Because I'm just amazed that virtually everybody here is in some science or engineering related discipline.
Yeah.
It's incredible.
Yeah, and it was, and this made me want to, you know, really though, where are they? How far out are they? You know, and is this going to shift over time, or do you maintain this? You know, and so another level of questions about this, but I do think the fact that most are still there is a great testament to students coming through the program and finding, you know, they're staying with it. And I think really making the case for the investment here has really been beneficial to meeting the overall goal of diversifying, I think, the workforce.
Now, those numbers add up to 100%. So I mean, this is not. This says of those who stayed in science and engineering, how are they distributed? Is that what
Yeah.
that's
Yeah.
not
It's
saying
100% of who
the percent that actually stayed in the field, right?
Say that again, I'm sorry.
Just of those respondents, how did and who were in science and engineering,
Right, well,
how were they distributed?
yeah.
It doesn't talk about those who are not in science and engineering.
Well, you could argue that the, yeah, and I guess if you broadly define science and engineering, including health-related, so it's all of our students who,
It's everyone who
It's
including
it's everyone who responded, and really trying to figure out what kinds of places are they,
No response is 1%.
So somebody responded but didn't say where they were.
they didn't say what kind of work they were doing. Yeah.
Just as a footnote, we developed another way of tracking students passively using LinkedIn. You can select LinkedIn, all the students in the PSM program, which we looked at 1,300 out of 6,000 graduates. We were able to tell who their employer was, what their job title was, and how long they were there. Also, we were looking at whether they stayed in the state where they had gotten this particular degree, because there's an interest on the part of the chancellor in arguing to the governor that they're training a workforce for the state. And we didn't have to do any interviews, we didn't have to ask them to fill out a questionnaire. We just passively looked at their LinkedIn, which is a very detailed self-statement as to who they are and where they're working.
Yeah.
Do you have any sense of whether students who are still in science and engineering would be more likely to respond?
So say that again now. Do I have?
So it's striking that almost everyone is still in science and engineering.
Yeah.
And I'm curious if, because your response rate wasn't, I mean, I think it was typical, but it wasn't, you know, it was a small percentage of your total. And I'm wondering if people are more likely to respond, if the survey was framed in such a way that students who weren't still in science engineering might have felt less proud. I don't remember how to right word, but you know what I mean.
And I think some of our response, lack of respondents, speaks to that a bit, because we used, so to affiliate with the dual degree engineering program, students just say, I'm interested. Now, when we look at then who shows up, seat in the intro to engineering course, smaller, much smaller numbers. So when I talk to the coordinator at Spelman in dual degree, you know, she will say, oh yes, we have 100 dual degree students. But you look at the intro to engineering course and it's 16 students, average maybe, you know, over a 5-year period, maybe 12 students. So somewhere in that process, they're self-selecting out. So often it's when they meet with the advisor, they lay out the program of study, they talk about what it takes to do this. And especially now over the years, so there's no pre-summer program anymore. And so their students could, you know, get at least, you know, 5 to 8 credits out of the way in the summertime. So you know, you take those things into consideration. It becomes almost a daunting thing about how am I going to do this, you know? And then you start looking at other alternatives for how you move through.
A question and comment, but it seems like you surveyed people who graduated with their dual degree. Is
Well,
that what this is, or is it people?
No, it was people who were affiliated with the program.
Okay.
Yeah.
For what it's worth, when we did our survey, we had a small response rate at the beginning, and I looked at the data, and we kept banging them with emails, and we were really aggressive to get our response, but we got a pretty good response. Interestingly enough, I was worried about that very same thing. Percentages stayed the same. It really didn't change. It didn't seem, you know, I was worried that we'd have this sort of unknown category grow as we kept being aggressive, but it really didn't, the percentages did not change.
Yeah, but I think...
Had we had 25%, it would have given us the same answer.
Really interesting.
But I think your point is, I think what we found is students who finished the program, they also sent the link on to, and it's a community of people who know each other. And so, so the folks who completed the program really, and there are those who did not complete, and so, and I'm pretty sure many of those who didn't respond were those who did not go through the program. So, yeah, that's a good point. Yeah. So I think, you know, we're all here perhaps talking about what's next for dual degree programs, and I think, you know, looking at this one as how it's kind of been this collective impact. There's been a lot of things operating to support the success of the program at Spelman and the Atlanta University Center. And you know, it sounds like there quite a diversity, I think, in how how the programs are structured at different campuses. And so this one you can see many resources have played a significant role in moving the program along. And as those programs, as those resources have kind of waned or gone away, there is an impact to the number of students who are matriculating through. And so some of the questions being asked are, what is next, or how do we address that? So anyway, I think that's been part of our discussion, and so I'm really hoping that we'll continue to toss that around. But I think I am fairly confident that the program at Spelman and Morehouse, because it was founded on this idea that many of the students coming into those institutions competing for a seat as a first-year student at an engineering school were not going to be competitive. In fact, I have one of my great friends, Calvin Mackey, who tells this story about he went to a career fair. Georgia Tech was there, Morehouse was there, and he goes over to Georgia Tech and they tell him he wants to be an engineer. He's thinking about it, and they ask him his SAT scores, and he tells them, and they say, oh, well, you want to go around the corner over to that booth, check out Morehouse. And so, you know, and this guy, amazing guy, so he tells the story of at Morehouse taking him, as many of our faculty say, they're, you know, diamonds in the rough, you know, but they polished him up, and he invested. I mean, he was told what he needed to do to get himself ready, and this guy started in remedial reading, you know, but he committed to closing that gap, and there were a lot of other support systems around him to help him do that. So he finishes Morehouse with you know, a BS in math, BS in physics. He goes to Georgia Tech. You know, he gets his master's in mechanical engineering and his PhD in mechanical engineering. And he becomes a tenured professor at Tulane University. But he's a motivational speaker, basically, was his segue. And so Tulane closed their engineering program a number of years ago. And this was even pre-Katrina, so, but anyway. So now he has a STEM camp in New Orleans for students. And just an amazing guy, but the stories of how the dual degree program really instrumental in helping the students be competitive and make the transition. And so it's been a good story for the Atlanta partnership, primarily Georgia Tech being a great partner right from the onset. And some of the other partners, Michigan now coming in, have really also made an investment. So we're hopeful, but know that there are some changes that are having to occur for the program. So thank you for your time, and let me share my story.
What was the name of the guy who ran that STEM camp in New Orleans?